Here's my finite automata for my 355 extra credit project. Here you can see the language we'll be using to implement today. Starting at Q0, we begin reading our input. After reading a 1, we move to Q0 or to Q1, which we can be in any state, which we can reach with an epsilon. Following that, you follow the epsilon to Q4. And once you're in Q4, you can no longer reach any epsilons, so you must either read a 1 or fail through accept. But here in our case, we read a 1, so we change our text to a 1. And then in Q5 again, we read another 1. So now we have read 3 1s in a row, which is defined in the string up here, essentially with 1 1 and a 1 1 right there. Now again, we enter Q11, which we have a bunch of epsilon transitions that can be reached. From there, we will go back to Q1, following our epsilon transitions to Q7, which is then followed to Q8, which we cannot no longer reach an epsilon transition. So we will read a 0, entering Q9. And then from there, we have a bunch of epsilon transitions that can be reached yet again from Q9. So all those are highlighted in the brighter yellow. Should be noticed that now we have read 1 1 1 and a 0. So now we will follow those states all the way up to Q12, which will go all the way back to Q1. And then following that epsilon transition again, knowing we need to read 1s, we come up here to Q4, we read 1 1, go to Q5, we read another 1, we go to Q6, and then once again at Q11, we have all these epsilon transitions that can be reached. So those are also highlighted. Going to Q12, we go back to Q1, then we follow those epsilon transitions yet again to reach our 0 iteration, I guess you can call it. And then once we hit Q8 again, we read a 0, go to Q9. Once again, epsilon transitions proceed. And from there, we follow Q10 to Q11 to Q12, which will then turn red on Q13 when it accepts.